Researchers have noticed something weird. Some learners who use AI tools experience no change in their learning speed. Maybe they're even a little faster in implementing their solutions. Others throw themselves at these tools and get worse. They might be able to generate working code, and they might even think they genuinely understand the problem, but ask them a couple questions like, can you explain why this approach would fail for larger inputs? Or, why did you use a binary search tree over a linked list? And their answers might get a little confused. To investigate exactly what is happening, let's consider an experiment.
A student is enrolled in an introductory computer science course. She has no previous experience with programming and doesn't consider herself to be very good at math and other technical subjects. In this course, the teacher allows for the use of large language models and AI code completion software to help students with their work. They figure it's not going away, so we might as well learn to work with it. When completing a homework assignment, the student carefully reads the question. The task says, please consider subscribing to JetBrains Academy YouTube channel and checking out our free IDEs and courses. What a weird question for a programming assignment. Wait, I'm on the wrong page. The student begins to code, and almost immediately, an AI autocomplete generates a long function, which interrupts her train of thought. In the pause, she realizes she doesn't know what to do. She turns to an LLM. The student knows it's better to use AI as a tutor rather than an answer machine, so she requests step-by-step guidance, not the full answer. However, after reading the first point of advice, she scrolls past the explanation in search of a quicker solution and then copies the generated code. This code does not fully match the problem and contains some unfamiliar syntax, leading to further confusion. After repeatedly passing her code back and forth between the IDE and the LLM, she eventually produces a version that passes the test cases, though without much understanding of how it works. Later, a researcher asks how useful she found the AI. The student answers, very useful, and it's like having a personal tutor, and I really need that extra support in more difficult classes like this one. Here, we see the problem. The student lacks an awareness of the way that she actually used the AI. She has a skewed perception of her grasp of the material. An illusion of competence clouds her understandings. In short, she doesn't know what she doesn't know. On the flip side, imagine another student in the same class. She once attended a STEM-focused summer camp and is familiar with the frustration of learning to code. She doesn't find it easy, but she has the experience behind her to know that she's capable of producing working output with a bit of work. When completing the same assignment, this student carefully reads the problem description, pauses to think, and begins structuring her solution. She knows she'll need certain variables to store the result and count, and she adds some comment to outline her strategy. As she types, the AI autocomplete provides frequent suggestions, which she occasionally glances at but mostly ignores, preferring to follow her own plan. When she does accept suggestions, they are small and deliberate, filling in predictable elements like closing brackets or simple conditionals. While she produces a few errors and syntax mistakes, she methodically corrects them and successfully completes the assignment, passing all test cases with flying colors. The experimenters ask her, how useful did you find the AI? She acknowledges that AI helped her move faster, but credits her own thinking for getting to the right solution. If these examples seem a bit extreme or manufactured to prove my point, I'd agree with you. Unfortunately, they are real. Our subjects were 2 of 21 students in the same introductory programming class who were observed by researchers with eye tracking and asked to verbalize their thought process out loud while completing the same assignment. The main findings of the paper suggest that generative AI can create a widening gap between people who find programming easy and people who don't. Other studies have backed this up, with some observing a higher failure rate in their courses after the introduction of these tools. This means that foundational concepts and prior experience are not just nice to have, but necessary for successfully using AI tools in programming. Otherwise, you're going to find yourself on the wrong side of that gap.
So what should we take away from all this? Well, no matter whether you'd consider yourself a struggling or a non-struggling student, you should assume that it is good for you to be able to code without AI tools. A simple rule of thumb is anything you'd ask an AI to write, you should be able to write yourself. There are a lot of good reasons for this. Doing things slowly is better for learning, like how writing your notes by hand is scientifically proven to be better for memory and comprehension. Additionally, coding with nothing but your own intelligence can improve your self-confidence. making you more resilient to imposter syndrome. It also changes the actual experience of coding. When you generate code with AI, you feel less ownership over it. This means it can be more frustrating when it doesn't work and less satisfying when it does. When you let something else do your thinking for you, you don't feel this same rush of satisfaction when the solution works. You don't feel smarter or proud of yourself. You just copied a solution and it worked, just like it was supposed to. It feels meh. If you're a beginner, this can eat away at the few experientially rewarding parts of coding in the time when you need that positive feedback the most. Not everyone can sit through hours of meh. For many, the experience of that rush, struggle, and eventual satisfaction are the best parts of the job, not something to be automated away. Of course, there is another perspective to this. What about using AI when your goal is not learning, but doing? I get it. It's a big field, and you might not always have the time or energy to invest in learning every little framework from scratch. If a personal project you thought you could finish in a few weeks is taking months to complete, I understand the temptation to vibe code the back end and come back to it later. In this case, I'm not completely against using it. I mean, the way a lot of us learned to program even before AI was not through diligent study and deep understanding of the material, but by hacking together code snippets from GitHub and Stack Overflow, waiting until they broke, and then debugging, crying, swearing we'd never program again, and then eventually figuring it out. I don't recommend this method. There are easier and faster ways to learn, but not everything has to be easy and fast to work. My general advice is to not use LLMs when you can help it until you feel confident in your own ability. When you can't help it, just keep these trade-offs you're making in mind. Foster an awareness of when your mind is using the LLM to take a shortcut that will make you a worse programmer in the long run. Just because you have an impulse to type in a prompt doesn't mean you should listen to it.
So, we know about the widening gap that AI tools can cause for beginners, and we know that making sure you're not on the wrong side of that gap can probably mean an emphasis on writing more code by hand, at least in the beginning. But there's a lot more to know about what concrete things you can actually do to improve your thinking. If you're interested in looking into the psychology of what is actually happening in your mind as you learn to program, you can check out our next video on that topic. As always, if you're interested in sharpening your computational thinking, we have free licenses for students and free programming courses you can complete right in your IDE at academy.jetbrains.com.
Thank you for watching. Please like and subscribe. Please. I beg you.